So, elements, compounds, and mixtures. Going to see what an element is compared to what a compound is, and what are mixtures. And then we look at the criteria for purity. So, because we're going to consider also pure and impure substances. All right, let's get to it. Now, any sample of matter that has the same physical and chemical properties throughout the sample is called a substance. So I'm defining a substance to you now. I'm saying that a substance is any sample of matter, could be anything, sugar, salt, water, any sample of matter that has the same physical and chemical properties throughout the sample is a substance. Now, there are two types of substances. We have element and compound. Those are the two types of substances, at least in chemistry. So, a substance that cannot be broken down into chemically simpler components is called an element. That's why you say an element is a substance which cannot be broken down into, you know how I used to define it, but I'm telling you the other way around to make sense to what I'm teaching now. A substance that cannot be broken down into chemically simpler components is called an element. Remember, I already built that any sample of matter that has the same physical and chemical properties throughout the sample is a substance, and that there are two types of substances, element and compound. That's one type of substance that cannot be broken down into chemically simpler components is what element is. Now, for instance, hydrogen, helium, boron, carbon, nitrogen, aluminum, the elements in your periodic table. A substance that can be broken down into chemically simpler components, of course, because it consists of more than one element, is what we call a compound. The fact that it consists more than one element is the reason why you can break it down to other simpler components, because if it contained only one element, you wouldn't be able to break it, because we said elements cannot be broken down. All right, so the substance that cannot be broken down into simpler substances is what we call elements. But the substance that can be broken down into simpler components because it consists of more than one element is called a compound. So a compound can be broken down, an element cannot. Water is a compound. Why? Because it's composed of two elements, hydrogen and what? Yeah, oxygen. So because of that, of course, we can break it down and say, okay, we have oxygen and when we have hydrogen. So that tells you that oxygen, which is an element, and hydrogen, which is an element, came together and made the compound water. All right. The formula for water is H2O. All right. A material composed of two or more substances is a mixture. Remember, we said substance can be element or compound. Now, if one material has a compound and an element in them, or it has more than maybe two compounds, one element, or whatever, is a mixture. In a mixture, the individual substances maintain their chemical identities. They don't change. So mixtures are composed of two or more substances, and these substances maintain their chemical identities. They don't mix, or they don't blend to become one new substance. Okay, mixtures can be homogeneous or heterogeneous. Okay, we are saying In some mixtures, the components are so, intimately combined that, they appear as a single substance. You combine a substance in such a way, you mix one substance with another to form a mixture, but these two substances combine in such a way that they, intimately mix up, and you're not able to identify substance A from substance B anymore. Then that kind of mixture is homogeneous mixture. Let's say you bring Coke, Coca-Cola, turn it into a glass. That's one substance. Bring in water and turn it into that. Maybe you put the Coke up to half of the glass, then bring water and add to that Coke to fill up the gas, completely fill up the glass. If you look at that mixture of Coke and water, two different substances, you will discover that you cannot tell where the water is and where the Coke is. Even though the color of the Coca-Cola may become lighter, but the lightness of the color, of the dark color, now mixes up totally. I mean, the Coke, everything just looks as if it is still Coke. You can't pick out water. So it's a mixture because it contains two different substances, Coke uh, and water, but they mix up intimately and you can't find the difference. So that's an example of homogeneous mixture, mix up uniformly. Okay, other examples are sugar dissolved in water. You dissolve sugar in water, it blends in, and you don't see the sugar again, of course, if it is still unsaturated. Then air is a mixture. Remember, air has nitrogen, has oxygen, has carbon dioxide, has the noble gases in that same air. But when you look at the air, if you can even see it, you don't see the different nitrogen moving in one side, oxygen moving in the other side. You don't see that because they mix up intimately and you can't identify one element as one substance from the other. So air is a mixture. Also, adding acid to a base becomes a mixture. Okay, mixtures that do not form a uniform composition, as do not mix up intimately, such that the different components of the mixtures can still be visible. No, it can still be visibly spotted. The different components that are made of the mixture can still be visibly spotted. These kind of mixtures are heterogeneous mixtures. Take for instance, you put a bowl of water, keep a bowl of water, and then you pour sand into it. No matter how you stir the mixture, the sand will still settle down and stay in one place so that you can still see the water is differently separated from the sand. Now, that's not like the other case where Coke and water mixed up evenly and you could not know which one was water anymore. This one that you can see the sand differently from the water not mixed up intimately is an example of heterogeneous mixture. Also, if you add oil into water, you know what happens, right? The oil separates its layer and stays in one side. And you can clearly see that the two mixtures did not mix up intimately. And you say that's an example of heterogeneous mixtures. So I'm saying we have two types of mixtures: homogeneous, which mix up intimately and you don't see the difference in the components that's mixed, and the heterogeneous mixtures, which is the opposite. You can see the components of the mixtures separating themselves out. They don't mix up intimately. Now, when do we say a substance is pure? So on the other hand, when do we say this is an impure substance? Pure substances are substances that contain only one kind of matter. You know, this can be just one single element like hydrogen, helium, lithium. Just hydrogen alone is a pure substance because hydrogen alone will just contain H hydrogen. Hydrogen cannot contain some sodium in it. That's no more hydrogen. That's sodium hydride. Helium will just contain helium. Okay, understand what I'm saying? Okay, let's say let me use water. Don't take this to heart too much. If you keep water in a glass and then use syringe and draw from one side of the glass and test it in the lab, what you'll be finding as the composition is H2O, H2O, H2O. Go and take use that same syringe, go to river, take up some water, go to the lab and test. You'll discover it's still having H2O, H2O. That means water is in this case now still contains H2O. If it still contains H2O, H2O, then it's a pure substance. But I'm using now single elements: hydrogen, helium, lithium, etc. They are all pure substances. Or they can just be one single compound containing exactly the same kind of matter. Okay, like if you combine sodium with chlorine, that's sodium chloride, right? You form sodium chloride, that's your table salt. As a salt in your kitchen is sodium chloride. And it's a white salt, crystalline solid, white crystalline solid. As I'm describing how the sodium chloride is, your white crystalline solid salt, and it has none of the properties of sodium or chlorine. You've mixed up sodium with chlorine, but when you form it, this new substance formed is sodium chloride, which doesn't have a property of sodium on its own and chlorine on its own. It just has a property of this new substance formed, sodium chloride. Okay, so the compound sodium chloride is a pure sample. Okay, it's a pure substance. But if you mixed sodium chloride with maybe ground pepper, granulated pepper if you want, you grind pepper and then it's powdered. Then you mix this sodium chloride, your salt in the kitchen with pepper. You mix it very well, mix it totally. You'll still be able to see the individual grains of each of them. You'll still be able to pick out pepper if you carefully look at it. It can be separated out from the salt. So this is example of an impure substance. So as I'm saying that impure substances contain not one type of substance. Okay, impure substances. So therefore mixtures are impure substances. So all mixtures are impure substances, but all elements or compounds are pure substances, right? Mixtures can be separated using appropriate separation techniques, which we'll discuss later. So mixtures are impure substances. Just put that as food for thought. All mixtures are all mixtures are impure substances, and all elements and compounds are pure substances. But how do we say this is a pure substance? I mean, why do we have to say that? What makes us able to say, yes, this is a pure substance? As I'm saying, what's the criteria for purity? All right. So the criteria for determining the purity of substances are based on the correct elemental compositions and how sharp the melting point or how constant the boiling point is. Okay, so if you are to melt the solid form of water, ice, to liquid, how sharp, if the melting point is 4 degrees Celsius, as you know, ice is 0 degrees Celsius. If it starts melting, because of the anomalous nature of matter, if it's melting at 4, if the melting point is 4 degrees Celsius, when you heat it up to 4 degrees Celsius, does it start melting? At all cases, as long as it's pure water, if it happens, then the melting point is sharp enough. Or if you are to boil water and it's supposed to boil at 100 degrees Celsius, is it boiling at 100 degrees Celsius? If you boil the second time, will it still boil at 100 degrees Celsius? The third time, the fourth time, another person boils. If it's pure water, does it boil at 100 degrees Celsius? What I'm saying, is it constant in boiling at its own boiling point? If a substance has a sharp melting point and a constant boiling point is not 100 today, tomorrow is 120, and it's still the same substance, a constant boiling point and a sharp melting point, then you can say that sample is a pure sample. All right. So once we have obtained a pure sample of a substance, we can use the following criteria to determine its purity. The melting or boiling point of a sample, that is to say, pure samples have a fixed melting and boiling point. Therefore, if the value of the boiling point, that's for liquids, or the melting point for solids, that you obtain, if they agree with the given standard in a book of data, sample, then it's said to be pure. The sample is said to be pure. A pure substance gives one spot on a paper chromatography. If you've done chromatography separation technique, where you can separate colors of the pigments. When I was small, we used to open our pen, blow the ink into water and watch the colors separate out. But in the lab, you can, put the ink on paper, and then the paper is dipped into water. One part of the paper is dipped into water, and as the water rises over that paper and comes across the ink where the ink is, as it's rising above the ink, it will be separating out the colors of that ink. That's chromatography I just explained. If it's a pure substance, when the water rises and passes that spot where you marked that ink, if it's a pure substance, as the water rises above it, it won't separate out colors. The fact that it separates out colors means that it is made up of more than one color. All right. So if it's a pure substance, you will just see one spot. It won't have different colors or separate spots. So this is used, example, in forensics to check the purity of colored substances. Now, density of the substance also should be constant. A pure substance has uniform composition and properties. So that's the criteria for purity. All right. Thank you.